Alright, so the first type of problem that we're going to do is learning target 7.1 at a basic level, which is just a mole-to-mole conversion. So if we read the problem, if you have 10 moles of C2H2, how many moles of oxygen gas are needed to completely react? So first things first, under C2H2, I'm going to write what I have, which is 10 moles. And I want to know how many moles of oxygen gas I need, which means I'm going from C2H2 into oxygen gas. So starting with what I have, 10 moles of C2H2. The only unit I have right now to cancel out is moles of C2H2, and I can go from moles of one compound into moles of another compound, so moles of O2 on top. Now I get my values that I put into this right from the coefficients in my equation. So for every 5 moles of O2, I have 2 moles of C2H2. When I plug it into my calculator, I take 10 times 5 divided by 2 to get my answer of 25 moles of O2. Moles of C2H2 cancels, and I make sure that my answer is correct. For letter B, how many moles of oxygen gas are needed to react completely with 3.6 moles of C2H2? So now, instead of starting with 10 moles, I'm starting with 3.6 moles, and I'm still turning it into oxygen gas. So same process as last time. This time in my first bracket goes what I start with, 3.6 moles of C2H2. The only thing that I can cancel out is moles of C2H2, and I'm turning it into moles of O2. My ratio is still for every 5 moles of O2, I need 2 moles of C2H2. When I plug into my calculator 3.6 moles of C2H2 times 5 divided by 2, I get 9 moles. Moles of C2H2 cancels. My unit is in moles of O2. For letter C, the ratio that I used is the mole ratio. And that's the ratio of moles in a balanced chemical equation. And the ratio of moles comes directly from the balanced chemical equation. Now you go on and try the next mole-to-mole problem.